Here we are supposed to give the products for these reactions and the alpha carbon. So alpha carbon, remember, is always going to be the one that is next to the carbonyl. So for example, this one has 2 alpha carbons. Okay, so in the first reaction that we have here, you have the ketone treated with hydroxide and then Br2. So the product we should probably get is substitution with Br. Okay, and so for the hydroxide, which proton is it going to get, alpha 1 or alpha 2? And alpha 1 is going to be more acidic, so that's the proton that's going to go away, which means that's where the substitution should take place. So which means that our product is going to be this. Okay, so alpha 2 is more substituted hydrogen or carbon, I should say, and so therefore the proton is not going to be that acidic, okay, because of inductive effect. Okay, let's look at the next problem, and in the next problem what we have is a ketone over here, an LDA, and we're adding 2 carbons, which means that we probably did not start with all these carbons that we have in here. So let's see, 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbons over here, and we're adding 2 carbons. So I'm looking actually for my alpha carbon, because my alpha carbon is the one that's going to be doing the reacting. So right here I have 2 carbons right next to the ketone, and carbon number 4 is the one that is attached to 2 carbons. So that means that's where these 2 carbons came from. So it means my starting material must have been this ketone. Okay, right here, no hydrogen there. And so the alpha proton that we need is going to be on this carbon. Once that goes away using LDA, LDA is a very strong base also used in aldol chemistry. And so once we take away that proton from here, then this nucleophile that will be created will now do the substitution right here, okay, to give you this long chain carbon. So again, aldol reactions are really good for forming carbon-carbon bonds. Okay, so that's what this reaction is about. The third one is a very specific reaction, and this is sodium hydroxide and Ki and I2. And this is also called the iodoform reaction, okay, or iodoform test also. So in the iodoform test, it's a very specific test that is used particularly for methyl ketones, okay, and this one is a methyl ketone because you have a methyl group over here. So in this case, you have an alpha proton. Of course, you have 2 alpha protons, but remember again that this alpha proton is going to be more acidic. So what happens in this reaction is not that you just get the one substitution like you got here with the bromine. So here you don't just get the iodo. So for example, if you're thinking that, you know, okay, I will probably get the one substitution with iodine, that doesn't quite happen, okay, over here, because the reaction actually proceeds more and more and more, and it takes away all the protons that we have here. Okay, so the sodium hydroxide will remove all of these protons, and so one by one you end up actually losing that carbon right there, and you end up getting the you end up oxidizing the ketone to give you a carboxylate, and then you also actually end up losing this carbon, and that becomes CHI3, and this is what's called the iodoform. So just like chloroform would have the 3 chlorines in there, this is the iodoform, and iodoform has 3 iodine in there. And the thing about this reaction is that because iodine is so huge, this compound will end up precipitating out, and because it's also iodine, the color that you get for this precipitate is yellow. It's a beautiful yellow color that you get from this, and so this is actually called the iodoform test, because if you're trying to identify ketones, different ketones, you can be as specific in saying that, oh, I got a methyl ketone. So for example, like acetone, acetophenone, those will give you then positive for iodoform test. Okay, so it's an alpha carbon chemistry thing.